Today we are going to discuss the group data. In the previous sessions, we discussed ungrouped data. The analysis of group data is here we are looking at the transforming observation into insights. Here we have data set, and in the data set we have identified what is the mean, median, mode, and Q1, Q2, Q3, and deciles and percentiles for ungrouped data. It give us some sort of insights. But when we are dealing with big data, big data means here the large number of observations, and dealing with the individual observations will not work. It will take a lot of time, and getting in-depth insight is very difficult, very challenging. So therefore, it's a technique in statistics. The common technique is grouping the data set. So in the era of big data, the primary challenge for management is not acquiring information, but interpreting it, right? So there are a lot of means, there are a lot of ways of collecting data, even in social media and other polls and other different means, data collection, a survey. Can collect the data. So for managers, collecting data is not a matter, right? Even though we have millions of data set in our hand, without doing interpretation, it's useless. So that managers have to develop their data interpretation skills. Interpret what are the meaning, what are the insights the data reveals. The deck this presentation outline statistical framework for organizing large volume of raw data. I have explained you what is raw data into coherent frequency distribution and visualization. Right? We discussed basic visualization technique like pie chart, bar chart, and column chart, and line chart. So those are basic. Right? The same principle may apply here, but if we have some different grouping set here, like this class. This is a class. Class mean here we group the data set. So this represented this class, this grouping include age. So for example, if we consider as an age, and this group consider 20, 21, 22, up to 29, right? So we grouped all this observation into one class. So that is grouping. So what's the objective of grouping data set? To equip managers with the tool to assess the risk, trends, and performance. Risk mean when they do investment, sometimes the investment may face losses. How to make some mitigations to reduce kind of losses. That is called risk management. And trend for marketing managers, they may want to focus the sales trend, demanding trend, pricing trend. So those kind of things managers need, so that this grouping data may help them to find out the appropriate trends. And performance and the divisional performance or employee performance or particular product performance has to be measured. For that instances, data grouping may help them. So data grouping, it's simply we make into classes. Management challenges, information overload versus summarized insights. Here, as I told you earlier, when there are a lot of more and more observations, it's very hard to get insights. Handling the data, handling ungrouped data is very difficult. So it gives information overload. So that what they do is they summarized the data set into groups. Data chaos, the problem. When the data contains a large number of observations, yet the large numbers, maybe thousands, millions, billions, right? Say, for example, Instagram, how many likes a particular post receives? Who are the demographic profiles for gender, age group, and geographical area, and how they have got impression, negative comments, positive comments, so those kind of things, in a minute there are a lot of clicks. observations. Right? Those are big data. So handling this kind of data is hard. So it is mathematically difficult to handle without grouping. So that to manage the data, the big data into manageable load, they are doing a technique called grouping, right? Grouping. Without grouping the data set, it's hard to manage them. Raw data, we already discussed what is raw data in the previous chapters, but I recall the raw data is defined as the data that is collected but not yet organized, right? In the raw form, uncooked form. The array, right? Raw data become array. It's a new term maybe for you, array. So even when raw data is sorted in ascending order or descending order list, the list is called array, is often fails to reveal the underlying story of the matrices. Like if I give you age of particular students in a class, you can arrange the data, right? So you can arrange the data small from high, or right, highest value or highest value to lowest value. Right? So descending, ascending order and descending order. So when we arrange the data set in order, ascending or descending order, it's called array. In programming language, we call them as a list and so on. So based on the context, they may have different names. So handling the ungrouped data is difficult, right? So difficult, and also it's hard to get inside the logics inside within the data set. Strategy clarity. The managers should get the strategy clarity on from the data sets, so that what they do to assess the important characteristics, right? Important characteristics like risk of the data set, risk of what are the implicit risk within the data set, what are the trends, performance. Managers must group observations into distinct classes. So based on the requirement, managers may group the data sets. This sacrifices granular detail for strategic perspective. In the ungrouped data, we are deal each and every observations so that no data is missing and each an observation getting detailed attention. But when we group the data set, sometime we may lost the data, the particular observation, granular details, insights. Here, this data set is grouped some of the way, so it is for illustration purpose. Let us work on the case study example. Rural bank account. Rural bank account balances. Here there are people in a rural bank. They are keeping balances, account balances in their saving account. So this data set represents 40 saving accounts in rupees thousands, right? Here, how many? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 into 10. For there are 40 data sets. Here, 40 data sets. And when we look at this data set, these data sets are not arranged. So these are in raw form, raw data. So what the observation here? Looking at this raw data set, can you instantly determine the dominant deposit range or the outliers? So by just looking at the raw data set, it is very hard to find what's the minimum value, what's the maximum value, and are there any trends, which group having more accounts, more balances, right? It's hard. So verdict, ungrouped frequency. So this is ungrouped data, ungrouped as well as in raw form. In raw form, ungrouped frequency distribution is inefficient. So right, this data set is inefficient for this volume. We need to group. We need a grouped frequency distribution. Now the next step we have to we make this raw data set into group data set. So group data set is somewhat organized set. Right. What are the steps do we have to follow to group the data set? You see, these are the account balances. So these each observations are raw data. We are not organized. So these raw data having 40 points, 40 data points. Now we write in a mechanism, using a proper mechanism, we group this data into 6 different groups. Summarized classes. We have six classes, right? 6 classes of the group data set. Right, step 1. So here, to prepare a group frequency distribution, we must first decide on the number of classes. How many number of classes we have to maintain? Here we have 40 data sets, and how many groups we need? First we have to decide that aspect. How many groups? Here we decided to make 6 groups. Are there any rule of thumb? Are there any rules for that? Actually, there are no rules, but there are best practices. A rule of thumb, analyst, right? The data analyst typically use between 5 to 10 groups, right? Between 5 and 10 groups, extending to 15 for very large data set. Sometimes you may go up to 15, but normally we can see 5 to 10 groups, 5 to 10 classes. The strategic choice for this bank account case study, we will utilize 6 groups to balance the detail with summary. Right? For this case, we may select six groups. Right? So that first we decided step number 1, how many groups. We decide how many groups. So this raw data set going to 6 groups. So this group is called classes. There are 6 classes, 6 groups. Step 2, calculating class width. Class width is nothing, right? Class width is this class width. You see, when you look at this, here the data, right? This group 20 to 29. No? So this is the width, and this is the width 30 to 39, 40 to 49. This is the width. This is called class width. Right. Once we decide the number of groups, second step is to decide the class width. Sometimes it's called class size. Class size as well. For that, we need to first calculate the range, right? Range mean the maximum value in the data set and the minimum value of the data set. In the data set, we have observed the highest value, the maximum value is 79, and the minimum value, the lowest value is 24. So the range is 79 minus 24 equal 55. It's a range, right? The range, right? The range, from the range, here, range, we already decided number of classes, 6. We decide to keep 6. The range, 55 divided by 6. So therefore, we will get 9.16, the class size, 1.96. Right, here we have to remember, always always approximate to the next highest value. Sometime you may get the value for another calculation, say 9.01 or 9.001 or 9.02. So even mathematically, when we approximate, it is equal to 9. But here, right, here you have to approximate to the next highest value. next higher value. So even though it's end like this, you have to make it into next higher value is 10. Next higher value is 10. If we round down, for example, so since this is a 9.9.01, then if we put this is 9, right, sometime we may lose some of the classes here. Example, we bring it to 9, the highest value in the data set might be excluded. Sometime we may exclude some of the observation. We can't include some of the observation within that class. So there's a risk. So therefore, in summary, first we have to find out the range. The range should be divided by number of classes as we decided earlier. Here the range is 55 and number of classes 6 and the class size, the class width is 9.16, and the rule is we have to take the next highest value, that could be 10. So therefore we can decide the class width could be 10 classes, 10 width. So the class width is 10. So therefore the final 6 groups, each group size is 10. Each group size is 10. Here, forming the class, right? Forming the class. So we have up to now we have number of classes, that is 6, and the class width is 10. Decide. Now we make the actual classes. Here we form equal sized classes. Equal sized class mean here when you see the class width 20 minus 29 minus 20, 9, here 9, 9 and 9, 9, 9, right? Even though it's mathematically we get 9, but the actual class width is 10. I will explain why. So here differences are 9, but class width is 10. I will tell you why. We form equal size classes, ensuring that one data value belongs to exactly one class, right? So here, when you look at here, right, 29. So we can, if into the class, in this class, we include any observations that fall within this range. We may include 20, 21 up to 29. And this data, right, this data set, we can include 30 to 39. But there are some, right, there are instances 29.7 or 29.6, 29.9 or 29.1. Where we include? Where do we include? So there's a gap. There's a gap 29, 30. So between 29 and 30, like the decimal numbers 29.2, 29.5, 29.7, right? So how do we handle, right? So for that we need to define the class boundary, right? Class boundary. So these are class intervals, and we have to decide, we have to, always that we have to decide the class boundary. So there's a rule of thumb. Starting point, since our, right, I will come to that point later. Right here, when you look at the data set, the minimum value is 24, right? In the data, when you look at the data set, here maximum value is 79 maximum value, and minimum value is 24. Minimum value is 24. Right. Here, since the minimum value is 29, maximum value is 79, we have to make the classes, right? The class intervals that make it easy, right? Make it easy. Sometimes, no matter, you can put 24 to 33, and 34 to 43, and 44 to 54, 53. Likewise, we can put, but when you put 20 to 29, 30 to 39, and 40 to 49, so 20s, 30s, 40s, right? You can put easily. You can put the particular observation quickly. So that in that purpose, we start the first class at 20. Right? We make the first class 20 to encompasses the lowest observation. Right here, look at here. So we make it into classes. We starting from 20. So therefore 20s. And you have to make sure that the largest value should cover. Don't miss the largest value as well. Here, how many classes as we decide? Here, one class, 1, 2, 3, 4, 5, 6. And you have to make sure that the highest value 79 also should be included in the classes. And keep in mind the class width always be equal to each other, right? It's called equal size classes, right? Here differences are 9, but we write the class with 10. It has boundaries. So it take the data set like this. So it is 29, this is 30 now, right? We have to find the mid value. 29 plus 30 divided by 2, which equal 29.5. So the actual range, right? Actual range could be 29.5. Here, starting from 29.5. So here, actually here, 19.5. Lowest class, boundary. Now you see here, the actual boundary. Here 19.5, 29.5, and 29.5 to 39.5. Now see the class width, right? Class width 29.5 minus 19.5. The differences are 10. So, right, in each class it should be 10. So that is called equal size classes. And also, if the value like 29.7, actually it falls in this class, and 29.4 it falls in this class, and 29.5, so where up to right here we can put here, or you can put here, but you have to define clearly, right? Less than 29.5, 39.5. If you define like that, 29.5 here, it should be here, right? I'll come to that point later. Now, based on the data set, so this is the data set, we have defined the classes. Tabulating the frequencies. The telemark, as we discussed in the previous classes, telemark method is used to tabulate the class frequency from raw data. Right here, in this class, we take 20 to 29 here in this data set here, and right, accordingly we divide the classes. We form the classes. There are 6 classes. Now we mark the telemark 60, right? It's fall on here 1, 52, 50s, 40s, 54, 30, 24, 37, 51, 40, 64, right? Like that we mark the tally, and finally we count all tallies here. 20s, 3 times, and 30 is 5 times, 40 is 10 times. Like that, we can calculate the frequency, the number of occurrences. So altogether, right, the total of frequency should be equal to number of observations. Should be equal to number of observation. Frequency we call F frequency, and this is sum of frequency. This is sum of frequency. Sum of frequency always equal to number of observations. So this is how we tabulate the classes. We form the class and enter the data in particular relevant classes. As I told you earlier, refining the view, right? Even though the class is the class interval says 20 to 29, right? The class limits and the true boundaries. Here, class limit. When you talk about class limit, so this is class limit 20, lower boundary, lower class. So the lower limit 20, upper limit 29 of this class, right? The class limit for this here, the lower limit 20, upper limit 29 of this class. But when you talk about the true boundaries of the class, 19.5 and 29.5. Why is that? Yeah, there is a reason. Here, the class limit actually range up to this point. This is class number 1 and class number 2. Class 1, class 2. And here there's a gap. That's a gap. So for example, in your observation, 29.7. Where we put this? So that we need to define the true boundaries. The true class boundaries are, for example, for the first class, 19.5, right? We bring it, right? Here, we bring it here, and we bring this model here, and we put 29.5. How we find this? 29 plus 30 divided by 2. Then we got 29.5. So this is the boundary. That's a boundary. Here, look at here for this class, the boundary 19.5 is the lower boundary of the class, lower boundary of first class, upper boundary of first class is this. This is lower boundary of first class, upper boundary of first class. And here, lower boundary of second class, upper boundary of second class, right? Here, when you look at here, the gap always, there's a gap between each classes 1, but when we find the true boundaries, the gap equals 0. Class mark, right? Class mark. Class mark is, this means a midpoint. Midpoint. That's called class mark. Establishing representative value, right? Mixed midpoint. The class mark is the midpoint of a class. It represents the entire group in statistical calculation. For example, here in this class 20 to 29, right? This is a class 1, first class, and second class is this 30 to 39. Here, what's the midpoint of this class? Midpoint, right? Midpoint we have to find here. We have to take the lower boundary, not limit, lower boundary plus upper boundary of a same class. Lower boundary and upper boundary divided by 2. Here, lower boundary is this 19.5 of this lower boundary, and this is 29.5, and divided by 2. And result is 24.5 is the middle value. 24.5 is the mid class mark. And when you look at this one, 29.5, 39.5, and divided by 2, we can get 34.5. So this is class mark. So we call them as X. Second class, right? Observation, the difference between consecutive class mark, right? 34 minus 25, 34.5 and 24. So the mid class 34.5, no? So this mid class 24.5. See the differences. Equal class with equal 10. So when you calculate class mark, the midpoint, the differences between the sequence of classes equal to class width. We already decided class width should be 10 for this calculation. Likewise, when you look at here, this is a class, no? This is the class. As we find the lower boundary and upper boundary, here 24.5, here 34.5, and when you calculate midpoint, you may get 44.5, here 55.5, here 64.5, and 74.5. When you see the differences, equal to 10, right? This 10, right? The differences should be equal to class width, right? Class width. That's what emphasized here. The differences between consecutive class mark equal with the class width. For this case, for example, 10. Right. The comparative analysis and relative frequency. So when you look at the table, right, when you look at the table, you see only what here. You can see here a table. That's the frequency distribution. So here it represents classes, it represents class and respective frequency. To get more insights, right? So this is absolute value. Absolute value mean alone. This class alone, it took 3. This class alone, 5. It class 10. But total 40. Now we want to show them here 14, right? 14. This class represent what? What the proportion? What the proportion of this class observation? Right here, there are 40 observation. Out of 14, represent this. How to calculate 14, 40. And here, this class 40 to 49, there are 10 observations. Total observation is equal to 40. Then 100. Then it represent 25%. So 25% of the observations are in this class. Likewise, we can see 14 over 40 into 100, and also we can get the percentage of that class. So this is called relative frequency. Managers need to compare data sets of different sizes. Absolute numbers. See, absolute number mean we take here only 10 for the class 10. We are not compare. We are not relate the number. That's why it's called absolute. Absolute numbers can be misleading. Percentage, right? Percentage provide context, right? Provide context. It may give, rather than saying 10 observation in that class, 10 observation or 14 observation in that class. But we say 25% or 1/4 or 25% of the observations falls in this class. So it's give more insight. a class here, calculation for class 9, 40 to 49. Class is here, frequency is 10 according to the table, and total observation 40. So it's easy. 10 over 40 into 100 equal 25%. So it is called what? Relative frequency. So the manager can understand. Yes, 1/4 of the observations falls there in that class. And handling complex data scenarios. As I as I explained earlier, so all those data points and absolute numbers, the integers mean the full number, 20, 21, 26, 30, 37, like that. So integers. When we get the values like uh, 32.7 or 35.2 or 39.5 or 39.8, so where we can put problem a value of 39.8 does not fit into the 30 to 39 or 40 to 49, so because there's a gap to place 39.8, there's a gap, there is a gap, so that we use what? Continuous definition. So it's mean here we put here, we have to read this class 30 and more, right? Like this 30, right? 30x, the value could be 30, right? 30 and more, but less than 40, less than 40. Less than 40. Right? So we have to read the data set in this way. Actually, right? So it's been what? 30, 30 and more than 30, 30 and more, and below 40, not including 40. 40 will be the next class, right? Here, this class represent 40 and more, but below 50, below 49, below 40, sorry, below 50, below 50. In that way, we have to read. So I tell it again. So here, this class 30 to 39. Right here, when we take the actual boundary, it's look like that, 29.5 to 39.5. So this is actually class boundary. Sometime non-statistical people may know, they don't know. So that's why when we write clearly, we can write in this way, 30 and more, but less than 40. Less than 40. The next class, 40 and more, but less than 50. Next class, 50 and more, but less than 60. Right? In that way also we can write, so that it may accommodate the decimal points as well. And one more scenario is called open class. Open class means, so each classes has its own boundary. Right? On boundary, for example, 20 to 29 and 30 to 39. So it has class boundary. What's the class boundary? It's a class boundary. Here 19.5, here 29.5. This is the class boundary for this 39.5 and 29.5. It's a class boundary. But there are instances we can't define it. We can't define the boundary. For example, income group. So we can say income like this, 0 to 10,000. 10,000 to 20,000, or 20,000 to 50,000, and 50,000 to 100,000, 100,000 to 200,000, and 200,000 to 500,000, and 500,000 to 1 million, right? 1 million, and 1 million to 10 million, and right, there are people, they are getting billions, right? Billions. So that, but very one or two observations. So that what we do is more than more than 10 million, more than 10 million. Which means any value, even in this class, it's open, and it get any value more than that values, right? More than that value. So this is what this is called open class. Open class problem. Yeah, problem. Indefinite. Indefinite outliers. Outliers mean extreme values. Extreme values exist in the data. Solution. Define only one limit. Only one limit mean here, for example, salary, uh, 1 million to 10 million, and more than 10 million. More than 10 million. More than 10 million. So this is what it has no upper boundary. It has only, right, each class has lower boundary and upper boundary, no upper boundary. But open classes has only one boundary. For example, here it has lower boundary only. Lower boundary only. And not only this, sometime we may put below 10,000, below 10,000 rupees. So it has upper boundary. It has maximum value for that class, but it may include all observations below 10,000. So it has also open class. It's open class. Visual example, less than 500. Less than 500 mean, so its lower limit is unknown. Less than 500. So it includes any value. So it is upper class. We know only this is upper boundary. And more than 50. So we know the low value, lowest value. So upper limit is unknown. In this way, we can make classes. Visualization. Right now, we look at how do we visualize the data, especially the group data. We use normally histogram. Histogram. Here, case study, factory workers age, and factory workers age. Here, the data is given, factory workers data. Here, age 20 to 24, 25 to 29. So this is different case, right? This is earlier, these cases about the bank account case, bank account balances. But this is new case. Here we are dealing with new case. This data is about factory workers and their age. Factory workers age and the number of workers in particular age. And they divide, they make classes 1, 2, 3, 4, 5, 6, 7 classes. 7 classes. And class width actually 5. Class width is 5, right? For each class, it has length of 5. So class width 5, and it is these classes are equal sized. Equal sized. And let's see the number of workers. So in this age group, there are 10 number of workers. This age group 16. This age group 22. And this age group 48. Right. So we have the frequency distribution for age group data. A histogram is a graph of vertical rectangles, right? It may have like bar chart, like it's like a column chart, right? Rectangles where height height is a proportional to the frequency. So if the height of uh, the graph representing the frequency, it transforms the table into visual pattern. Here you can see here we present the data in a histogram, in a visual form. Here, what are the points you have to be careful on that? Here, this is x-axis, so y-axis. Y-axis, you have to put the frequencies. You have to put the frequencies. What's the frequency here? Number of workers. Number of workers. It range where minimum is 20, maximum is 54. This class and the class workers here, what do you hear? This is 48. Frequency maximum 48. Frequency maximum 48. So this is the top value. So you can put up to 48. At least you have to have up to 48. Number of workers maximum 48. And this is the highest frequency. And you see the x-axis age in the class right here 20 to 24. But we know the actual class boundaries are 19.5 to 24.5 and 24.5 29.5. In that way we write the class boundary. And here in the histogram you have to write the class boundaries so that there are no gap between the classes. So class boundaries continuous, no gap. And you see the bar must touch to signify continuous data, right? So here, since there are no gaps, so these are touched, right? Those are touched, and you should know that note that the width, right, of each class should be equal size, and the height represents the frequency. Right? Here, first class 10, second class 18, third class, and here fourth class 48. Likewise, you can draw the histogram. But when we look at the histogram in the visual form, you can get some insight very easily. You see this one. This is the highest. Highest means the peak. Peak is mode. Highest frequency data with highest frequency 48. So this is the mode. The peak, the highest concentration of workers in the 34 to 49 age group. There are 48 workers. The spread, you see here, the workforce range, the age range from 20 to 54 years. You can see the range as well. The trend, the distribution rises steadily to middle age and decline sharply. You see, when you look at the workers, those are middle age groups. Middle age group, 34 to 39, middle age group. The factory relies heavily on mid-career workers with fewer entry level, right? These are the entry level people, very young entry level people, and near retirement people as well here, very very young and very old. There are very minimal numbers with fewer entry level or near retirement employees. So by looking at this histogram, it's easy to find the insights, meaning of the data set. Now you can understand we can transform raw data into a group data. For group data, first we have to decide how many groups we have to make, and then what's the class width, and then we put the tally marks right? And we can put the frequencies. Raw data, right? Summary and key terminologies, what we discussed. The raw data is mean unorganized observations. The data, we keep the data as it is. And class limit. Class limit mean the stated endpoint of a group. Class limits, endpoints. So these are the lower limit. This is upper limit. Class boundaries, the true mathematical limit. Here, 19.5. This is 29.5. And class mark is the midpoint of the class. And the histogram is the continuous graphical representation of frequency. So closing thought, grouping data sacrifice individual detail to gain strategic perspective. This transformation is the essence of managerial analytics. So it's what does it mean? Here, for example, age 20 to 24. And say in this class, this class does not have any 21 years old or 23 years old, but it may have only 22 years old, 20 years old employees only, and it may have only it may has on all 10 belongs to this age. But when we look at the class level, it interprets as so there are employees, there are 10 employees. This range, the age range may be 20 to 24. But when we look at the individual level, this class represents only the 22, and it may hide the information. There's no age group. There's no age people having 21 and 23. But so this kind of uh, individual observation may be that insights we may lose. So that's the major disadvantage of grouping data. But these are those disadvantages are not big. It's not a big an issue. But anyhow, we have to get more insights in that way. In while we lose data precision when handling the group data. So that's all about today's session. If you have any doubt, you can unmute your mic and you can ask questions. Any questions?